Here. It is great to see everyone. I saw a lot of comments there in the chat from people all over the world joining us. I'm in London right now. It's actually sunny in the UK for once. I saw a couple of people joining from the UK. Can you imagine it's sunny today? So it's great to see everyone. So, like Abigail mentioned, I currently work as a senior developer advocate at Microsoft. I focus on Python and AI. And for this talk today, I'm going to be walking you through a practical guide to agentic coding. Now, before I get started with the talk, I do want to mention that I'm on all the social media sites. I'm chronically online. So if you have any questions that were not answered after this talk, feel free to reach out to me at any of the platforms that are listed there on my slide. A final thing here as well is that you can use the link on my slide here to access the slides that I'm sharing, or you can wait. Jan is going to send out the link as well. So you'll have all of the slides available for you, because I know that's a question people tend to ask. All right, so diving straight into things, here is a bit of an agenda of what we're going to be covering in our talk today. The first thing we're going to look at is the evolution of AI and coding. We're going to understand what a coding agent is and what something called an agentic loop is as well. And then we're going to walk through some practical demos of how to work with agents, coding agents, to get the most out of them and the best results. And then finally, we'll look at some best practices for when you're working with coding agents. A good question for us to be asking, and hopefully you are here on this call to learn, is what is agentic coding? Some context for us to have is that over the past, I would say 2 years or so, we've seen this massive shift in AI assisted programming. So, in the past, initially, when we started to see AI appear in our code, it was through code completion. So, maybe you would be writing a function, and as you're typing, an LLM would look at the last 2 or 3 lines of code that you were writing, and then the LLM would make some suggestions of which lines should come next. And you could accept or reject those suggestions just like you would with your phone with autocomplete or something like that. Then after that, the AI labs, like OpenAI and Anthropic, started to develop these LLMs that were specifically made for coding. And in this stage, we started to be able to go to ChatGPT, to go to Claude in the browser and chat with it, asking it to generate a function or an entire script. And I remember during that time, I would go over to ChatGPT and I would ask it to create a function for me, but I would have to copy the code that was generated and paste it into a file. Or I can remember sometimes I would get the code that ChatGPT has given me and I would try and run it locally in VS Code or something like that. And then there would be an error. So I'd have to copy the error from the terminal and paste it back into the chat so that I could get some help with the problem. So this era was fine. It was great because we were seeing the LLMs getting better at working with code and solving our problems with code. But there was a lot of manual work with that copying and pasting into our environment. And then I would say probably around the beginning of last year, we really started to see the emergence of true agentic coding. In VS Code, for example, we introduced something called agent mode to GitHub Copilot. So if a user is using GitHub Copilot in VS Code, when they switch over to agent mode, it turns Copilot into this autonomous AI programmer. So if I go to Copilot and I now ask it to complete a task for me, Copilot is able to execute commands in the terminal. It can complete multi-step tasks using the tools that it has, and it can even debug its own code. So you have a higher level of autonomy. And I would say the specific thing that changed is that we've given the LLM access to our full coding workspace. So it's not just working in a chat, but it has the full context of our workspace. And it also has access to specific tools that allow it to, when it sees, okay, this needs to change, or I need to add this, then it has the tools it needs to be able to make those changes by taking action with those tools. So in the market today, there are a lot of different coding agents, and we're really at an inflection point, I would say, where there's a bit of a fight for which coding agents are going to come up on top. But this is great because it provides us with lots of different choice. So regardless of where you prefer to use your coding agent, there's lots of options. If you want to use an IDE, so say for example, GitHub Copilot and VS Code, you can do that. If you want to use your CLI, Claude Code has been very popular for that. In the web, you can use things like Codex as a coding agent in the cloud. And then you can also build your own custom coding agents in code using different frameworks. For example, LangChain is a great example of an SDK you can use to make some custom coding agents. So I will say that even though all of these different coding agents, we have such a wide variety, all of them under the hood typically are built the same way. And for us to be able to know practically how we can take advantage of these coding agents and get them to produce the best results possible, one way to do this, I would say, is to understand how these coding agents work under the hood. So let's start by defining what an AI agent is. Now, it's been debated in the past, but a widely accepted definition of an agent today is an LLM that calls tools in a loop to achieve a goal. So that's pretty much accepted in the industry as what an agent is. And I would say specifically for coding agents, we see them, often in almost all the coding agents, they are associated with this agentic loop that you can see on the screen. I actually got the image that you can see here from an article that the team at Anthropic published about how Claude Code works under the hood. And for the rest of this talk, because I mentioned it's going to be demo heavy, we're going to be trying things out live, we're going to focus on these three parts of the agentic loop. So gathering context, taking action using tools, and then verifying the results. So let's go ahead and start with the first part of the agentic loop, which is gathering context. Now, if you're a user and you go to your coding agent and you ask it to complete a task for you, you're sending in a prompt to your coding agent. The first thing the agent is going to do is it's going to try to gather context that will allow it to be able to complete the task on your behalf. And there, I would say, as someone that is doing agentic coding, one of your top priorities should be to make sure that your coding agent has the correct context it needs to complete a task. And there's a number of different ways today that we can give our coding agent access to context. One of those things, so you'll notice that right now I'm presenting the slides in VS Code. I'm using something called Simple Browser to show the codes, but to show the slides. But I just clicked on this chat button and it's opened up GitHub Copilot, the coding agent that is GitHub Copilot. If you want to install that, for example, in VS Code, you can just go to the extensions tab and look for GitHub Copilot chat, and that will install it in VS Code for you. Now, once I've opened this, this chat session, I want to make sure that I've clicked on agent here, and that's going to make sure that Copilot is ready to act as a coding agent for us. I mentioned this agent mode before previously. And then you also have options of which coding models to use. Let's go ahead and use Claude Opus 4.5. I usually have a wider variety of models to use, but for the moment, let's go ahead and use that. Now, one of the most common ways that we can give our agent context is to attach that context to the chat that we're using to talk to the agent. So here in VS Code for Copilot, if I click on this Add Context button, it's going to open up a list of different options for context. So here we can see there's this GitHub Issues option, and I can literally just click on an issue So Copilot is going to auto detect which issues are associated with my repo, and I can attach that issue to the chat and can ask Copilot maybe to work on this issue and fix it. Another option is maybe to go and attach a pull request for review, or we can actually go in and click on a file to give Copilot, and it will use all of this context to be able to know what to do. One of the top complaints that I hear from developers today when they're using coding agents is that they feel that the LLMs are generating code that is overly complex. Maybe the code doesn't follow the standards they like. And something that I like about attaching context is, for me, I have gotten into the habit of creating an example file. So I'll have a file where in that file is some code. Typically, I'll use APIs or functions that I use over and over again in my coding process. And I'll attach that to the chat and let the agent know, hey, this is the file that you need to use as an example, as a reference point when you're generating new code. So it looks at that file and it'll know that it should follow the conventions in that file and use that as a baseline when it's trying to generate new code. So that's one way that we can go ahead and help the agent in this part of gathering context. A second way we can do this is by providing an agent with instruction files. So if you've been in watching the coding space for a while, you've probably heard of these file names. So if you're working with GitHub Copilot, they will be called Copilot instructions. If you're working with Cursor, they're called Cursor rules. For Claude, it's Claude MD file. For agents, it's agents.md. We've tried to push for a standardization, and agents.md seems to be what's going to be the standard in the future. But basically, these instruction files are going to be used as a place where you can tell your agent how to behave. And the instruction files, any of the ones listed in this list, when they are added to a .github folder, that is going to control how your agent that you're working with behaves. A way to show this practically is I'm going to open up this simple agent folder. I mentioned in one of the slides that you don't have to just use one of the pre-built agents. You can go ahead and use code to build out your own custom agent. So in this example here, I'm using GitHub Copilot SDK to be able to create a coding session. So this line here will create a brand new coding session. I can change the model. I'm just using GPT 4.1 because it's the lowest energy model to use. But you can really choose any model that you would like to use to drive your agent. Then you can pass through different tools and different MCP servers and decide what sorts of permissions you want to give to your agent. And then I'm going to use this line of code here to pass through a prompt to the agent that I've created here in the code. Now, to run this code, I'm going to open up a terminal. I have too many terminals open, but it's okay. And I'm going to run this Python script in the same way I would run any other Python script. So I'm going to run Python simple agent.py, and it's going to get that agent session started, and it's going to pass our prompt hello copilot to the agent. Now, can you see the response? I'm not sure how many, if I hope I'm zoomed in enough, but you'll see, I'm going to zoom back out. But it says, hi, I'm Marlene's AI assistant for the ACM Tech Talk. How can I help? This is a bit strange because if we look at our folder, there's nothing in this folder that's talking about the ACM. Absolutely nothing. And the reason why our agent is behaving in this way is because I've created this .github folder, and then in that folder, I've created this copilot instructions.md file. It's a simple markdown file, and I'm going to define in this file the way the agent needs to behave. So in this case, I've told Copilot to, whenever the user says hello to you, when they greet you, you should answer by saying, hi, I'm Marlene's AI assistant, and so on. This Copilot instructions file, because it's at the root of the .github folder. So you can replace this with cursor rules. You can replace this with a Claude MD. But because it's at the root of this .github folder, it's going to affect any agents that are created, whether that's in the SDK or whether that's here in the chat. So I'm going to say hi again to Copilot that's here in the chat. And when I do, it should also give me this response saying, hi, I'm Marlene's AI assistant for the TikTok. How can I help? And again, the reason for this is because this file, when it's at the root of this .github, is going to be the instructions for the full repository. So anywhere you have an agent, it's going to be affected by this. Sometimes you don't want an agent that affects the full repository, and maybe you want a specialized agent that you use for specific tasks. And so in this case, what I would encourage you to do is to create an agents folder. So in that same .github folder, you're going to create an agents folder, and in it, here in this case, we're using that agent.md sort of file structure. And we are also putting the name of the agent we want to create. And then in this file, again, it's just a simple markdown file with instructions. I'm going to define what this agent is going to do. So I'm saying you're a reviewer agent, and this is what you do if a user comes and tries to use you as an agent. This is what you need to do. So this particular agent is going to be helping with reviewing code. So I can add some context here for specific requirements I want the agent to keep in mind when it's reviewing code. And again, this is in an agents folder, and then I save this agent.md file. One thing that you'll see is that if I create this file, I can come here and I'll see my reviewer agent has been recognized and it's listed as a special agent here. And so when I switch over to the reviewer agent, I can type in hi. And instead of defaulting to the Copilot instructions, it's going to default to the reviewer agent, and it'll tell me I act as a specialist agent for reviewing code. How can I help? So this is a great way of using context in different ways. We looked at adding context directly to the chat. We looked at creating a repository level Copilot instruction. And then we also looked at making a specialized agent like our reviewer agent here. So let's switch back to the overall Copilot agent mode. Great. So now we have a good understanding of context, and our agent, if we follow those specific, if we do at least some of those three things, our agent will hopefully have the right context it needs to carry out a task. Now, the second thing we want to take into consideration is action. And here we want to make sure that our agent has the tools it needs to, once it has all this context and it's made a decision on what it needs to do, we need to help it take action. And the way we would do that is by giving the agent the tools that it needs. Typically, in coding agents today, most of them will give you the option to configure the tools that your agent has access to. So here, I clicked on this tools icon, and it gives me a list of all of the tools that the agent has available to it. You can see right at the top that it's quite standard for most coding agents to come with some built-in tools. And some of the tools you'll see that are built in almost all the coding agents are an editing tool to help the agent edit files in the workspace, an execution tool that will allow your agent to have access to the terminal and maybe also execute code in the background using a sandbox. And then you also have a read tool that will help your agent read in the space, a search tool, a to-do list tool. And one of my favorite built-in tools is the web feature, so that your agent has access to be able to find information online and help it with the specific tasks. And so these are built in. However, if you are someone that's doing agentic coding, whether you're a developer, a PM, a designer, you probably have other tools that are not part of these built-in tools that you want to also give your agent access to so that it can help you with tasks. For example, I have this bicep tool that I've added on top of my built-in tools. If I close those there, you'll see these are a couple of the tools. So this bicep tool, I give it to the agent when I want the agent to help me deploying a model for deploying an app, for example, if I wanted to do this. So And one of the most consistent ways that we can give our agent access to tools is through something called MCP or Model Context Protocol. So, Model Context Protocol is an open protocol that was created by Anthropic that is it's a standard way, or it helps standardize the way that we provide context to LLMs. So a provider, maybe Microsoft, for example, will create a server, an MCP server that you can connect or give to your agent, and it will help it access the context, including tools from a specific API. And I would say that MCP has been very controversial recently, but in most interfaces, when people are using coding agents in their IDE, or for example, in on the web in the cloud with Claude, for example, MCP is the standard way that we are going to provide our agent with external tools. And one way that you can give your agent access to MCP servers is to, in GitHub, in VS Code, I would click on the extensions tab here, and then I'm going to press add MCP. And when I run that, I get a list of different MCP servers. So say, for example, I want to give my model access to Supabase so that it can, I don't know, do something with databases or whatever it is, Tavily for web search or whichever thing I want to, a tool I want to give my agent, I can just go to this list here. And some people are concerned sometimes with the security of MCP servers. I would really recommend using this feature in VS Code because all of these MCP servers are part of the GitHub registry. They've been vetted by GitHub, and we know they come from the original creators. So this is a great way to sort of avert some of those security concerns, though there are others that you should think about as well. And once you install an MCP server, it's going to appear in the list of tools. So all of these tools here with this logo, that's the MCP logo, have been installed as MCP servers. And you can see I have the Excalibur MCP server installed, and I'm going to ask it as an example for you to see today. I'm going to ask it to use the MCP server, the Excalibur MCP server, which I showed you I had installed, to draw me a quick diagram that will help us understand what MCP is. And you'll see that the agent has already connected to our MCP server, the Excalibur MCP server, and it's using that read command. The MCP server is providing it with the context it needs. Oh, it's already generated the diagram as well. So what's happening is here we'll see our agent is going to um, here we're going to see the agent has used that README tool to connect to Excalibur, and it's going to read the context on how to use Excalibur to draw a diagram. And then the agent is going to also use this Excalibur MCP server with the tools from Excalibur to then generate a diagram using that MCP server. And so here we have this very pretty diagram that shows us exactly how MCP works. So this is one example of how we can use use MCP as a tool for us to be able to complete a task with a coding agent. Okay, so that's MCP and a way to use that. Now, another way to give your agent access to tools is through something called agent skills. Now, agent skills are different from MCP in that it's a reusable workflow that's defined. You have, as part of your agent skill, you have a skill.md file, and that is going to be a workflow that an agent can invoke to complete a specific task. So, say for example, there's a task that I do over and over again. And in this case, I have an example for you of a skill. And again, the thing that we're doing here is we are going to that .github folder and we're creating a skills subfolder in there. And then I have an email skill. So I like to use agents to draft up emails for me, send emails sometimes, because that is my least favorite part of my job is dealing with email. And so here, a skill.md file is going to have it's just going to be a markdown file that has some YAML at the top. And the first thing is that there'll be the name of the skill, and then there's going to be a description for what the skill does. And your coding agent is going to read this description and will know whether or not to use this skill to achieve a specific task. So our agent would read the description and know that it can use this skill to send an email, for example. With skills, they're particularly good because you try to bundle everything that the agent will need in this folder. So here I specifically give the workflow instructions saying that the agent needs to pass through the user's request for an email to be sent to this agent.py file. And you'll see the agent.py file is here already included as part of the skill. So a skill is mainly a bundled way to give an agent a complete workflow. It can include MCP servers in as part of the skill for the agent to be able to complete a task. Now, to show you what a skill looks like, or using a skill looks like in agentic coding, I'm going to show you an example in the terminal. Before I do, I want to kind of set this up as a story so that we can understand what we're doing. So let's say I'm a developer that is working for a toy company called Tailspin Toys. Yesterday, I got an email from the search product management team asking me to add a search bar and filter to the site. They want some new features added to our website. And they've given me a short checklist of what to build, including a search bar with text search for simple searches and Azure AI search for more complex searches. They've also asked me to add in a sidebar so customers can filter by category and price. So this is a helpful list, and maybe I'm really busy and I can't do this work on my own. And so I want Copilot to help me with the task. And so to do this, we're going to use Copilot CLI. And so I'm going to just run the command to get Copilot CLI started. And when I do, you'll see things similar to what we were seeing in VS Code. It connects to a number of different MCP servers, to 4 different skills, 4 different agents as well. And when we look at the skills that are available, you'll notice there's this work IQ skill. For Copilot, I'm going to just exit out of that. And for Copilot, let me just go ahead and hide this floating meeting control. For Copilot to be able to help us with the task that we saw in the email, it somehow needs to connect to the to our email and then bring that information here into the terminal. So in the prompt that I showed, that I just had that I sent through to Copilot just now, I'm going to ask Copilot to use the work IQ skill to help me get the information from my email and pull it into the terminal. So work IQ is a skill that was created by Microsoft that helps you connect to the M365 suite. So in my prompt, I'm telling Copilot, find the latest email from the Tailspin Toys PM team and then list out the checklist of what we need to build here in the terminal. And you'll see that Copilot it's evoked that WorkIQ skill, and it's passing the question through to WorkIQ saying, find the specific email. And what's going to happen is in the background, this is of course like one that's coming from a company, but it will look very similar to what we just saw in VS Code, where under the hood, the skill is going to be using the Graph API as part of the skill.md file, to be able to triage through my emails and to try and find the right email. And fortunately, sometimes the demo gods are not on my side, but today they are. And fortunately, it has found the email from the team, and it's been able to print out all of the requirements that we need to build for these new search features. Great. So now that we have all of the requirements here in the terminal, maybe we want to also switch out different models. So here in Copilot CLI, I can actually call the model. Let's do that /model command. And then it gives me access to all of the models that are available. And again, one thing to note with agentic coding is that I would say to try and look for a way to have as many models that you have access to as you can, because the models are improving so quickly that sometimes it's hard to keep up with which one is the best option. So, for example, in Copilot, there's already GPT 5.4, but last week, just a week ago, people were excited for GPT 5.3 codecs. So, I'm going to choose 5.3 codecs. I'll set it to medium, and that just means the model is going to think with a medium amount of strength. And then I'm going to send through a prompt. I'm going to ask Copilot to, now using the checklist that it has, go ahead and build out those features that are here in the terminal that we've just seen listed out. Now, because Copilot CLI is also a coding agent, just like what we saw with GitHub in VS Code, it's going to do exactly those steps. So it's going to analyze the prompt that we give it. It's going to gather as much context as it can. So it's going to look around at the environment. It says it's planning its implementation step. So it's going to create, use the tools it needs to just read through different files in the code base so that it gets it right before actually starting to work on things. So again, in the CLI even, we're using that same agentic loop where you're going to have your coding agent gathering that context. It's going to use the tools available for it from it, and then we'll try to verify. So this process is going to, of building the implementation, the new features, is going to take a few minutes. And so while it works in the background, let's switch over to a new tab. So earlier today, I sent the same request for the search bar and the filter to Copilot, and I asked it to add the changes it made to a PR. So we can see this is the PR that it's made and should have the new search bar and filter. Now, I want for Copilot to use an MCP server here in the terminal. And when I press that /MCP command, you'll see I have a Playwright MCP server. And I would like for Copilot to go ahead and use this server. Just going to hide this when I press exit. It sometimes does that. I want Copilot to use the Playwright MCP server to help me manually test the features that it has. So here we can see that Copilot has, oh, I don't think I think it's starting to test from the other terminal, not here. I want to test properly here. So what I'm going to do is I'm going to ask Copilot to use this MCP server, the Playwright MCP server, to test the search and filter features using Playwright. So Playwright is an open source testing framework that was built by Microsoft, and it allows you to automate the browser, run manually automated checks in your browser. So when I ask Copilot to use Playwright, it's going to immediately launch the browser. And here you can see it's going to do things like typing in different inputs. It's going to navigate to different pages, click on different buttons to be able to test that all of the features are working. You'll see my hands are not on the keyboard. It's all Copilot. It's all Playwright that is running these different tests. And you see it has just tested the dole, and it's now testing out the categories for which toys are in a specific price range. So I have actually told Copilot to, as part of its instructions here in the terminal, to always use Playwright to test a feature. And I think that's why it launched earlier, because as part of its process, it knows that not only does it need to generate coding tests, it should also manually test its features, the features that it's created using Playwright. So we can see that our search bar is working as expected, and we can also see that the filter is working as expected as well. You'll also note that for each test that Copilot runs, it saves the test to a screenshot folder. It's taking a screenshot. Whenever a test works successfully, it'll take a screenshot, and then it's going to save that screenshot to a folder here. So going back to our terminal, we have now, because we did Playwright, we saw a skill in motion with being able to use the WorkIQ skill to pull in information from our email and have that information be in the terminal for Copilot to build. After that, we also saw some verification. And I think that sound here is just showing us in the other terminal. You see, it tried to run Playwright as the test there, and I had to close it, so it's asking me for more feedback, but I will come back at another time. Um, but here for verification, what I would say is when you are asking as part of that agentic loop, I would make sure to provide in your Copilot instructions some instructions to tell the agent to make sure to write unit tests and to verify that the code coverage tests pass by running those tests itself. The problem is that oftentimes we sometimes see agents writing self-affirming tests. So it will write a code test saying, if this code works correctly, print yes, and it will just print yes by itself. And so there's no clear verification that the code tests are the app is working as expected. And so this is why I would say using Playwright is a great way to add that end-to-end functionality for your agent to make sure that it's working as expected. All right, great. So far we have covered the entire agentic loop. What will happen is that our agent is going to, like we said, gather context, take action, will verify the results. And once it has the results, will either, it's either going to go back to you as a human and ask you for more context to see if you like the work that was done or if it needs some extra context from you. And then it will repeat the process, or it will complete the process and say it's done if you're happy with the results. So this is pretty much all of the practical things that we've looked at. Let's go over some best practices as a last note. So for context specifically, we talked about how we have a skill.md file and agents.md file. And there's research that has come out recently that it's so important for human beings to write or curate their skills.md files or their agents.md. When a human curated their skill.md file, the performance of the coding agent increased by 16 points. When a human told the agents just to generate their skill, it actually had a negative impact on the agent's performance and actually made the agent overthink or things like that. The same with that agents.md file in their tests that they run. It's just another group. They found that when a human would go ahead and provide an agents.md, it would have a 4% increase. But then if an AI agent was to create the agents.md file, it would have a negative effect. The LLM with the agent would start to overthink and it would increase inference costs by 20%. So important for us as humans. We still have a very important role with the context part there for sure. And then a second thing with best practices is version control. So say, for example, the agent had finished building out that search bar and the filter, and I wanted to make some other changes. I need to make sure that I'm committing the first version of those changes because once the agent moves forward, it's not going to remember some of the original code. And so the best way to do that is to commit those changes. And agents are very good with GitHub. They're very good with Git, so they'll be able to look back at the commits, reverse anything that's needed, and so on. I'll say that now, because we can generate the code faster, you're able to prototype on different branches. So I would recommend, you creating a new branch whenever you want to maybe create a prototype of the same feature. As a final note for version control with pull requests. At GitHub, so I work very closely with the GitHub team, and one of the top complaints from open source maintainers is that they're getting so many pull requests from people who are using their AI agents to generate pull requests. And the maintainers are getting overwhelmed and they're saying, please, some maintainers are completely stopping accepting pull requests. So for open source to survive, I would say let's try to be mindful of the PRs that we are sending to different repos. If it's your own repo, have your agent go wild. It can create as many PRs as possible. If not, let's think before we have our agent submit a PR. Also for critical code, I gave a talk recently, the same talk, and someone was saying all code is critical. And I don't really know, however you would define critical code. I would say that you should have a human review that code along with an agent. So maybe you can have that custom reviewer agent, but make sure to also have a human look at critical code, because you can really, we've seen agents, getting it wrong with security issues or maybe performance issues and their regressions there. And then the final thing, I mentioned that with these playwright tests, when the agent tests manually, something I've liked doing is having the agent putting in that Copilot instructions to have the agent attach the screenshots that it's taken to the PR when I'm requesting, when I'm adding a new feature. So I'll use a PR like that on the screen. All right, so we've covered a lot in the last few minutes. We looked at the evolution of AI and coding. We looked at the definition of what coding agents are and how they use this agentic loop. And then we looked through some practical examples of how to give an agent context, how to give agents tools, and also how to verify both using unit tests and also with manual verification with Playwright. And then we looked at some final best practices on context, making sure, encouraging humans to pass in the context, and also with version control as well. So I think we have some time for questions, Abigail. You can also, just as a reminder, find the slides there, but Jan will also go ahead and send a link to the slides. So yeah, let's get into some questions.
Yeah. So first of all, thank you for that excellent and practical overview of agentic coding. We had over 53 questions now, but we're just going to take a couple.
Okay,
Um,
I'm going to stop sharing my screen. Okay.
yeah. So there's one question from Lance White that says, how smoothly can you build these agents out with locally inferenced models or having multiple agents running locally?
So I do think that I'm so sorry, team. I'm trying to find a way. Let me share the screen instead for the moment, but I'm trying to find a way to see the chat as well. But yes, I think that it's very possible to use local models. There are some models like the Quen models that are entirely local that have been trained specifically for coding. And I would say the next generation of coding models, I would definitely think are going to come from the local models, because you're going to save a lot of money by just using a local agent to run these coding loops. So there are specific coding models. I will say these are big models. They tend to be pretty big. There are smaller models that are also sometimes used for coding, but I haven't really tested any that I've been blown away by. I think the Phi models from Microsoft are reasonable, but I wouldn't say they're right at the same level as some of the newer ones here.
All right. So Zoe is also asking, how much context should one use during agentic coding sessions? Can there be too much information?
Yes, absolutely. Oh, and you know what? I should have shared my screen for that, but I won't share my screen in this case. But one of the things you'll see, and I think it's a feature in most of these coding agents these days, is there'll be like a little spinner that will tell you when the agent is reaching its content max. So the agents definitely get to a point where too much context is going to degrade performance. And there's actually a certain amount that is known that once the agent has all of this amount of information, it's going to stop working well. So you want to, again, people are calling it context engineering. With a lot of these pre-built agents like Copilot, they have, as part of this harness that they have a way to manage the amount of context that they pass to an agent, or maybe once it gets that limit, it's going to compact and summarize the context so that the agent can continue with, the good amount of context that it needs. But yes, it's absolutely a great question. It will degrade if you overdo it with the context.
All right. So we have another question also from Dave. See, how do we give an agent access to one folder containing code without giving it access to the entire computer?
Hmm. So, for example, when I was showing you on the screen, the agent only had access to my IDE and to the workspace I was working in my IDE. So when you actually install or when you're using your agent, the folder that you open up the agent in is the folder it's going to have access to. If you wanted to control your full computer, you'll have to download a desktop app like this Copilot Cowork, which is Anthropic has Cowork. And so that's an option for giving it full access to your machine. But at the moment, actually, what I was showing you was really contained to the folder that, or the repository I was working in there.
All right. So I know that towards the end of your talk, you touched on some best practices,
Mm.
but there's a question on best practices, but I think this person gave some context to their question. It says, what best practices do you see for agentic coding and environments where source code tickets or internal issues cannot be made directly accessible to the agent due to
Mm.
privacy or compliance constraints?
Yeah, so I would say there are a number of different ways to do that. I definitely would look into local models or getting a sovereign environment. This is something that Microsoft is kind of pushing at the moment, which is kind of this sovereign AI, where you have an isolated environment to run your agents and they have specific models that will protect the privacy. You also have an option to add in maybe some middleware or some code that will encrypt the data before it's sent to the LLM. If there's sensitive parts of your data, you can have some code available that you can run that data through and then add in some encryption before it's then passed over to the LLM. This definitely makes it much more complicated. So I would say there are a couple of different resources online that I would look into for that. But best practice, I say, if you can access local models that are you can use entirely on your machine, the Quen models are fantastic for coding. Quen models can all be used locally. You don't have to access a cloud. You don't send your data anywhere and you can use that in an isolated environment.
Okay. All right. Thanks for sharing that. So we'll take maybe two more and then we'll end the session for today.
Okay.
So one question is from Maria. It says, when you prompt the agent,
Mhm.
does it just append the instructions to your prompt each time?
Yes. So there's really it depends on the how the harness. So whichever Copilot coding agent that you're using, the person who built that agent will have made a decision on how that context is going to be ingested by the agent. Once you attach it to the chat, it will look like it's appending the information to your prompt. And that's typically what they do. But different people optimize this in different ways depending on the coding agent. But that's typically the process
Okay.
of what happens.
Okay. Wow, there are lots of questions.
Okay.
Uh, but
Find
yeah,
me
Eric,
online afterwards.
yeah,
DM, send me a message.
yeah.
I'm happy to answer your question.
Yeah, we'll take one from Eric. That is, are there differences between MCP and skills?
Mhm.
Can agents call a skill that includes API contained in an MCP?
Great question. Yes, I try to emphasize that the skill is go your skill can contain an MCP server. So your skill is going to be like this package. People have also kind of thrown around the idea of creating like a central skills registry. You know how there's NPM or there's PyPI for Python. People have kind of thrown around this idea of creating like a skills packaging place. And the reason for that is you can put so much into your skill so the agent will know exactly what to do with it. So you can include MCP servers in your skills. The MCP servers are basically going to be the tools. The skill itself is going to be the holistic inclusion of the workflow. So we'll have the instructions, we'll have the different servers, the different tools, the different APIs. If you have a script somewhere you want to include you can include all of that in a skill, and including the MCP servers. Yes.
Yeah, yeah. So this is a shout out and a follow-up. So Rishav says that this was a nice introduction. So congratulations to you, Marlene. And
Okay.
they also want to know if there are any pointers where they can learn more about this.
Yeah, so I think follow me online. And I try to post there, but I definitely will also recommend the Anthropic blog post is genuinely such a great resource. I think the Anthropic blog is my favorite resource on agents because they always put out very high quality content there. GitHub also has some great blog posts on agents as well and agentic coding. And I typically try to get involved in quite a lot of live streams. So if you see any live streams online, that's another great way to see practical examples, especially if you want to actually see someone using an AI agent or agentic coding. A live stream is great on YouTube. So yeah, those are my favorite resources at the moment. Probably the top one is Anthropic's blog, to be honest.
So definitely, please try to follow Marlene on social media. She's very active. Definitely follow her and then reach out and ask questions, share some insights that you took out of this session as well. You could also put it out there on social media, keep the conversation going, sharing about what you learned from this session as well. So I would like to thank Marlene again for her informative presentation and insightful answers to the many questions. Unfortunately, we couldn't go through all the questions, but I know she's going to spend some time going through all of them and trying as much as she can to also keep sharing online for all of us to keep learning. So also a special thanks to each and every one of you for taking the time to attend and participate today. Um, this talk was recorded and it will be made available online in a few days. But also specifically, you can visit learning.acm.org, where you can also find some announcements on some of our upcoming talks and other ACM activities that you can participate in. Also, please fill out a quick survey where you can suggest future topics or speakers, which you should see on your screen in a moment. Now, on behalf of ACM, Marlene, and myself, thank you once again for joining us, and I hope you join us again in future. This concludes our talk and our session for today. See you all soon.
Thank you, everyone. Appreciate you joining. Have a great day.
Wow.